Okay, new unit. Breaking ranks here a little bit. We've been spending a ton of time talking about trigonometry as it relates to the unit circle, non-traditional stuff like analytical trigonometry where we were doing the verifications and the simplifications with those identities. We did some polar equation stuff and the polar coordinate plane, so some non-traditional trigonometry concepts there. We're going to head back into something that's a little bit more, I would assume a little bit more comfortable for people, and that is trigonometry with triangles, right? But even when we were talking about trigonometry with triangles in relationship to the unit circle, it was always with right triangles. We're going to be starting the law of sines today, which deals with oblique triangles is the name. Oblique basically encompasses all triangles that don't have a right angle. Okay, so acute and obtuse triangles, okay, scalene triangles, isosceles triangles, equilateral triangles, so everything that could be considered not a right triangle. The trick to this is that we can only use the law of sines in a triangle if we know two angles and a side, okay? So it could be an angle-angle side pattern, it could be an angle-side-angle pattern. And then we also have this, which I'm not going to say out loud and have a recording of myself doing it, but there'll be a way to keep, remember what we're talking about here with this. We can use the law of sines in what's called the ambiguous case. The ambiguous case comes up with a situation like this. There'll be another video on this down the road a little bit. Okay, but just a couple of basics before we really get going here. This would be an example of an oblique triangle because it has no right angle. We typically, and you're going to see this in the homework in the book and anywhere really, we label our angles with capital letters and we label our sides with lowercase letters, okay? And the sides are always labeled with the corresponding letter here, so like the angle A, the side opposite that is side A and C and B and so forth. So they're not going to say, when you're doing some of these problems, they're not going to say, you know, the side length of A is, they're just going to say lowercase a equals, and they're going to assume that you know that they're talking about the side opposite angle A, okay? You should recall that, you know, everything that you learned about triangles back in geometry still applies here. You know, the angles here have to add up to 180 degrees, that's still important. There's also some of the lesser known theorems and properties where when you talk about an exterior angle like this angle is equal to the sum of the two remote interior angles, those are called, right? For the same reason, this angle plus this angle makes up 180 degrees, and this angle plus these two angles make up 180 degrees, so the sum of these has to be equal to that. We're also going to rely very heavily eventually on what you remember about parallel lines and transversals in this topic when we start looking at some of the applications of this stuff. And another thing that needs to be said, I put an example. Let's see if I not get it? There it is. Okay. Suppose you're doing a problem and you get it. You solve a triangle and you get all of this information. Okay. Take a quick look at that. Pause the video if you need to. There's something conspicuous about this information that should not sit quite right. All right. You know, you look at the angles, 30 plus 80 plus 70, that's 180 degrees, so that's fine. You know, you have these side lengths. Let's talk about the side lengths first, right? In order to create a triangle, the two sides, okay, that are opposite this side or the two other sides from that side, the relationship of those two sides is a big deal, right? So if, for example, this was 5 and this was 1 and this was 9, okay, you've got to be careful there because, you know, if a side length that's 5, if you have a side length that's 5 and a side length that's 1 and a side length that's 9, okay, how's that going to form a triangle? Okay, you've got to be careful with these side lengths, and even more than that. And again, if I had a better manipulative here, we'd talk about it. Here's the other thing. Okay, take any triangle. The best case is with an obtuse triangle. So if you take an obtuse triangle, okay, something that looks like this, right? What's the longest side in this triangle? Right, it's this base down here. This side right here is the longest side in this triangle. It is across from the largest angle, and that has to be the case. The shortest side has to be across from the smallest angle. Like, that has to be true. Okay, so when you look at this information, when we're solving some of this stuff with triangles, the thing you need to keep in mind is, even if you get answers, check to make sure that they're reasonable. Check to make sure that they actually form a triangle, right? Because in this, the largest angle is 80 degrees, it would be angle B. And these numbers don't match up here, let's be clear about that. If angle B is 80 degrees, side B cannot be less than side C, right? Okay, so we've got to keep that in mind when we're doing these problems and you get to the end and you get your answer. Make sure that it actually makes sense. Make sure that the angles add up to 180. Make sure that the longest side is across from the largest angle, which is not here. So what we would say is, here we would say no triangle possible, or no solution, or no such possible triangle, or no such solution exists, or something like that. Okay, so just a few random facts about triangles that you want to keep in mind as we're going through this material.